Alright, you guys, first assessment is out of the way. On to Unit 2. A lot of this will be review because it has to do with limits. Most of this you've covered from pre-calc, especially today's digital lesson will be from pre-calc. And was feeling a little bored today, but I'll put it down. It's better, I feel more excited now. So a quick little review. Most of what you guys are going to deal with today have to do with graphical limits. So you're just looking at where the graph is approaching. So remember what your notation is as this function approaches this value from left to right, or if no sign is given, then we're approaching this value from both sides. The function is going where? So as we approach 1 on the x-axis, we're working our way towards 1. We're zooming in, zooming in, zooming in. And what are we approaching? A limit is not asking what you get, it's asking what you are approaching. So in this case, as we approach 1 from both sides, since no side is specified, it looks like we are approaching 2. It's kind of an ugly 2, but a 2 nonetheless. So the limit here is certainly 2. And then we go a little bit faster through the rest of these. So as we approach 2 from the right side, well, that plus sign means we're coming from the positive direction, so we're actually moving left. So we're way out here and getting closer and closer and closer and closer and closer. And then we bend away from 2. This is 1, there's 2. So what are we approaching? Well, we're going down forever, right? So this is not wrong. We are approaching negative infinity. But that's not a value that you can actually approach. Keep in mind that's just an idea. It would probably not be incorrect for you to write this, that it does not exist. I've seen both, actually, but this is probably more accepted than this is, because there's specific instances where the limit does not exist. So from negative 1, from the negative direction, so from the left side, we're moving in the positive direction as we approach negative 1. Only from this side, we're approaching 1 as we come from the left. Now what about 0? Well, no side is specified, so as we approach 0 from both sides, well, we're getting the same value, we're getting 2. And then as we approach negative 1 from either side, so here's where that case pops up. We go back to number 2. So I'm approaching it from the right side, I'm approaching it from the left side, and here's when a limit does not exist. The limit from the left is not the same as the limit from the right. From the right, the limit is 2. From the left, the limit is negative 1. Those two things do not coincide. So here is where the limit does not exist. So I've just got a few more of these to work through and kind of refresh your guys' limit skills. So I'm required to show you this as per the AP Calculus College Board requirements. This is the definition of a limit. You don't need to memorize this, nor do you need to know this. But if you guys get into higher levels of calculus, advanced calculus, maybe some analysis when you guys are in college, you'll start to speak in terms of these values. Basically what it says is we have a graph, and we have some function on this graph. There's f of x, here's the x-axis. And so what we're going to do is we're going to zoom in on a point, and we're going to get infinitely close to it, so we'll call this the point. We don't know what's happening at that point, but we can get infinitely close to it from the left and from the right. So as I zoom in really, really close from this side, or I zoom in really, really close to that side, and I make that smaller and smaller and smaller, what's happening? Well, I will automatically be zooming in along this curve. As I condense this space, the dot will get closer and closer and closer from above and below. And eventually these lines will get so infinitely close to this point, we just say that that's what the point is. We literally get the point. Do you get the point? So that's basically what's happening here. And this is a delta, this is an epsilon. Typically delta is used here, and this is positive delta away, and then this would be a positive epsilon and a negative epsilon. So you're that far away from the limiting value, which we call capital L. None of this will be on a test. You don't need to know any of this, but I'm required to show it to you. So back to stuff that you guys are more familiar with. So here's another graph. probably a good idea. Can I get it all on one screen? Oh, I can. Good idea for you guys to pause it really quick, give them all a try, and then come back and go through them with me. So, pause. Welcome back. So, let's go through them really quick. -6 from the right. Here's -6 coming from the right side. Looks like we're approaching -2. 3 from either direction, it better be the same. It is. It's -1. 0 from either direction, it better be the same, and it is not. As we approach 0, I see the asymptote there. We're going to 2 different places. So this does not exist. Number 4 is not asking you for a limit, it's asking you for an output. If I input -6 into the function, what do I get back? Well, at -6, we're undefined, we're defined right there. This is the coordinate, -6, 6 on this function. So our input is -6, our output equals +6. The limit as we go to -6 on both sides, again, it doesn't exist. The limit would approach -2 here, it would approach +2 here. So this one is a D and E. And then what about number 6? As the limit approaches infinity, so as we go to the right forever, what's happening? Well, this is the shape of a parabola. It's a piecewise parabola. Can't really assume that, but I do see the behavior is continually growing to the right. So as I go that way, the arrow says I'm going this way. So as I go to the right forever, this is going to go up forever. And then -2 only from the left. So as I approach -2, I'm coming in, and I get to here, I'm going to approach 0. It actually hits 0, but the limit from the left is 0. Alright, and then one more set to go through. Short lesson for today, since you guys just took an assessment. I'll give you a little breather. Fake niceness for once. So let's see if we can get this all on the screen here. Yeah. Okay. So a couple asymptotes here. Pause. Alright, welcome back. So as we approach -3 from the right, well, here's -3. We want to come from the positive direction, so I'm just going to hit 0. -3 from the left, so now we're coming in here. Looks like we're getting infinitely close to 4. And now a -3 from both sides. Well, this is a dead giveaway. These two answers would have to be the same in order for this to exist, but it doesn't. Those two answers are different, so the limit does not exist. F of 8 is not asking for a limit in what we're approaching, it's asking you for what it is. The function is defined at 8 right here, and it gives us a value of 3. Input 8, output 3. Limit as they go from 2 to the right, so we're approaching 2 from this side, pick up back here, and we are approaching 4 again. As we approach -infinity, so that means we're going left forever. Looks like this thing is flattening out. We're going left forever, and this is going to get infinitely close to this asymptote. It's going to get so infinitely close that we may as well eventually just call it 6 anyway. So the limit is approaching 6. And what about 5? Kind of tricky here, but as we come to 5 in both directions, it is going down forever. So this is consistent. Both sides of the asymptote are approaching -infinity. So we can write -infinity. It's probably more correct to write that. I would not mark it wrong. I would accept an answer of does not exist in that case. So it's a quick bit of review. That's all I really want you guys to cover today. Nice, easy, light digital lesson. This is your homework. Already gave this to you guys after the quiz. You probably could have done it without seeing my video, but you're going to see my face every day. I know it's painful. You guys have to bear with me. So give this a shot. If you guys have questions, let me know, and I will see you tomorrow. All right? Peace.